Hello guys, welcome back. Today we are going to understand today Leetcode question. Okay, so let's see the today question. So today we have given 1802 maximum value at a given index we have given in a bounded array, right? So let's continue to understand this question, right? So this is a Leetcode 1802 question. So it is saying that you have given three positive integers, that is n, index and maximum. Okay, and you want to construct an array that is called nums, right? And it is a zero index array, means only array that satisfies the following conditions, right? The first, it is saying that nums dot length is equal to n. Another, it is saying that nums at I is a positive integer where I is greater than or equal to 0 to n, and absolute value of num at I minus num at I plus 1 is less than or equal to 1. Now it is saying that I should be greater than or equal to 0 and should be less than or equal to n minus 1. Next, sum of all the elements of nums does not exceed maximum. And finally it is saying that nums at index is maximized. Okay, these things we have given. So what we have to do, we have to return the nums at index of the constructed array, right? And note that we have to absolute x equal x if x is greater than what, 0 and minus 1 minus x. Okay, so let's suppose we have given n equal to 4, right? And another, we have given index equal to 2 and maximum we have given is 6. Okay, so now we have to construct an array, right? And so how we will construct the array, right, depends on this value, right? So if let's suppose we have n equal to 4, right, means 4 is a length, right? 4 is a length, as you can see here. Nums dot length is equal to n, means length of array we have given in where, in here, right? N equal to 4 means when we are going to construct an array, so there should be index 0 comma index 1 comma index 2 comma index 3, right? So these elements we have to fill in the nums, and this is nothing but our nums, right? Now what we have to do, now we have to construct in such a way that the maximum should be 6, right? So nums at I is a positive integers, right? And we have to take absolute value num minus num plus 1 should be less than or equal to 1, right? Now it is also saying that the sum of all the elements of the num does not exceed maximum, right? So from the maximum it should not be maximum value. So to do that, if we construct a value, let's suppose I'll start with 1, okay, then we can take 2, then we can take 2, and then we get 1. So if it an index 2 has a 2 value, index 2 has a 2 value, right? We have given, this is given, right? Index 2, right? Index equal to 2 we have given, right? So if you consider that nums at 2 now is what, the if you do the sum, it will become what, there is no array that satisfy the condition, right? That satisfies the condition, and so we have to construct the array like this, 1 2 2 1, right? Because this is the only one array that satisfies our all the conditions, right? So if n equal to 4, if we'll take index 2 is there, right? If we'll do the maximum of this one, so it will come 6, right? So these all conditions can be satisfied, right? So here if we'll take nums at what, 2, so this will become what, 3. Why? Because we have to take the sum, right? We have to take the sum, okay? And 2 is the maximum nums at 2 is the maximum nums at here, right? You can say maximum value we can say, okay? and that's why this is the value we have given, right? So 0 1 2 is equal to, it is a 3 value it is coming, right? But if we talk about 2, what is this 2? 2 is the maximum nums at 2, right? This is the max num at 2, right? That we can see. That's why we have to return this 2. Okay, so this is your output. Okay, so in this way you can try this example too, right? And you can make it. Okay, so actually it is saying that num at 3 and num n equal to 3 6 we have given, index equal to 1 we have, and maximum is 10, right? So you have to construct in that way only. Let's suppose we have given n equal to 6, index we have given is 1, and maximum we have given is what, 10. Okay, so if we will write the array, so arrays would be have length what, 6, 0 1 2 3 4, and the last element is 5th, at index 5th, 0 to 5th. Now you have to fill this nums array, nums, right? So you have to fill in such a way. Let's suppose I'll start with 1, just for understanding 1, then we'll take 1 again, okay, and 2. So 1 1 2 is 4, we'll take 2, right? 1 1 2 and 4, or we can say 4 and 3. Let's suppose I'm taking 3. Okay, 1 1 2 and 3 is 7, and we'll take what, if I'll take 4 it will become what, 7 for 11. Okay, so I'll take 3, can take 3 and 0. Let's suppose, just for understanding, you can take any other value. Okay, and then at index here 1 we have to take what value, right? So it is coming 3. Okay, so you have to take initially 3 value, and then we have to construct like this. Okay, so you, at that time you will get 3. Just for understanding, leave it. So take time and do the solution of example 2. Okay, so this question has been asked in Oracle and Microsoft. Okay, let's understand the solution, what solution is saying, and how we will going to implement this, right? So as we know, these conditions we have given. Okay, so let's start with the example that we have given in the problem statement that we are going to refer through this figure. Okay, so there are several ways to make nums at 2, okay, the maximum, as we are going to see. First 2 example we are going to see is let's suppose once we want larger nums at 2, that we are talking about here, and it will become what, is 3, right? And the sum of the array will certainly be the greater than the maximum, right? Because 1 2 and 2 is what, 5, right? And this one becomes 6. Okay, so 2 2 4, 1 will take what, 1 and 1, so this total sum become 6, right? So when we take this value 1 1 2 and 1, right? So in this case what will happen, maximum 1 1 2 and 2 4, and this is 1, and this will be 5. So this is also true, right? And here what we are getting, we are getting 4, okay, my value. Now let's suppose we are taking here 3 at this index, right? 1 2 3 we will take here, right? And become 2. So that time 3 and 3 is 6, now we have 2, so this will become what, 8, right? And it is more than max value, right? More than max value is 8, right? And that is not good, right? Because here what we are getting, 3 3 6 we will get here, right? But the total sum will come what? Total sum will come 8, and that is more than the max value, right? So this way we have to understand, and then we will implement the function, right? Let's suppose we are going to use greedy or binary search, right? So the first our intuition should be, like, our objective is to maximize the nums at the given index, right? So nums, to maximize the nums at index, the nums at the given index, while ensuring that the sum, the array does not exceed maximum, so we can try using greedy algorithm, right? And in order to maximize the nums at index, we need to ensure all the other values as small as possible, right? So however, we cannot take the other values to be you can say smaller, right? And we will refer the two given rules in this problem, that the difference between the adjacent number cannot be greater than 1, right? And nums at I must be positive. Okay, means that we are talking about here, this will not work, because if we'll make the difference between these numbers, so this will not work, right? So you have to take like this only, like if you'll talk about 1 2, difference is 1, 2 2, right, difference is 0, 2 1, right, difference is 1, means it should not be greater than what, 1. So it is saying that if I'll take let's suppose nums at I is, let's suppose 2, so it is saying that nums at I plus 1 should be either 3 or 1. Okay, either 3 or we should take 1. Okay, it should not be other than value, because if the difference is coming, if we'll take this minus this or this minus this, it should not be greater than 1. Okay, next rule is saying that if nums at value let's suppose nums at I must be greater than 0, right, positive value. So these two conditions we have to follow. So the last two example that we have seen, right, here, these two, right, this was working, and as you see, the difference between the adjacent numbers are coming what, 1, right? But in the example of the right side, this one, okay, what happening here, if we are taking difference between nums at 3 and nums at 4, that is greater than 1, right? But in this example, if the first number is coming equals, right, the first number is coming equals, and which is not allowed. Okay, here those two example is coming equals, right? So that is not correct. So in this way, this is also not allowed. This example is also not allowed, but we are referring this one, and this is also not allowed, right? So only this type of example will work. Got it? Because both adjacent value is coming what, 1, difference would be what, it should not be, cannot be greater than 1, right? It cannot be greater than 1. So this should be take care of, and the difference, the next two values should not be equal, right? If it is equal, means what, this is also not right, this is also not allowed. Got it? Now let's suppose we are here. Okay, okay, so hence we need to ensure that nums at I satisfy these conditions as well, means this will not work and this will not work. Okay, this will not work and this will not work, this will work, right, based on these two conditions, right? If the difference is not greater than this one, right, and another nums at I should not be greater than 0, should not be 0, right? It should be must be positive number, right? It must be positive, not 0. yeah, must be positive, as you write, right, like this. So therefore the straightforward approach is, after setting the value of the nums at index, let the numbers to its left decrease one by one from the right to the left until they reach 1. Similarly, the numbers to the its right decreases one by one from the left to right until they reach 1, right? So this way means it is saying these are number given, right? These numbers are given. Okay, so the very straightforward approach, after you set these values, right, let the numbers to its left decrease one by one. So from here we are going to decrease one by one. Okay, it is saying like this. Similarly, the numbers to its right decrease one by one from the left to right. Okay, from right decrease one by one from the left to right until they reach 1. Okay, so these two approach we can follow either this way or this way, right, until we reach, so left side it will numbers should be decrease, right. This way we can ensure that the total sum of the array is minimized without violating the rule, because if we'll decrease, we will decrease by 1, right, if we'll increase, we'll increase by 1, right. So we need to calculate the sum of the array, which is purely mathematical problem, right. So let's take the number of left of nums at index, okay. As an example, right, there will be an arithmetic sequence to its left, right, and possibly consecutive numbers of ones s is nums at the given index is less than the number of element to the left, right. So we need to determine the length of the arithmetic sequence based on the relative size of the index and value, right. So the next value, that its relative consecutive value will come from what? Index plus 1, right, and if we'll do the minus, it should be 1, right, absolute value of 1, you can say. This will always come positive. So once we have determined the length of the arithmetic sequence, we can calculate the sum of the sequence using the arithmetic formula, right, and this sum will come, right, how, like a of 1 plus a of n dot n by 2. Okay, so this arithmetic sequence formula we will use, where a of 1 and a of n is the first and the last term of the sequence, where n is the sequence, last sequence, right. So let's suppose we are going to take here. Okay, so what I told the formula, so I am taking the sum as a of 1 plus a of n, and we will multiply with what? N by 2. Here a1 and an are the first and the last term of the sequence, and n is the length of the sequence, right. Let's suppose we are started from here to here. Okay, so it is saying that if the value here is less than equal to index, right, it means in addition to the arithmetic sequence from value to 1, there will be a continuous sequence of 1s with the index minus value plus 1, right. The sum we are talking about, like there will be index, right, minus value and plus 1. If this will come, right, it means what? Means where value is less than equal to index, and that's why here it is come value and there it is coming index. This way you are talking about, because we are we are just adding one value here, right? So one value is here, one value is here, like this we are setting for all these values, right? So the sum of all the elements, right, on the index of the left including nums index is made by two parts. The first part is, you can say, 0 1 2 3, right? And then it will come what, it will go continuously like this, and then it will start with what, this part, value minus 1, value minus 2, value, and then value, right, like this. And which is value plus 1 into value, like if you implement this one, this part, so this part will become what, value plus 1 into value by 2, right, like this it will become. So the sum of the sequence will become what, if we'll do the sum, if we'll going to find the sum, it will become what, index minus value plus 1, and which is, it is consist of all the one value, right? Now this index minus value plus 1 is the sum of your values, right? Otherwise it means there is only one arithmetic sequence on the left side of the index with the first item wing value and the last item value minus index, right? So first item will become what, value, and another will become what, value minus index. So this is your first value and this is your second value. So this time the sum of arithmetic value will become what, this is your value minus this is your, you can say, value minus index, and then we can take what, value, and then we'll take value minus 1, like this, right? So this all depends on your things, right? Either we'll take value minus index, value minus index, that we can see down, then value minus 1, and third we can take what, value. Three things we can take. In first we'll take minus, then we'll take what, minus 1, and then we'll take value. And then if we'll do the sum, right, and this will become what, value plus value minus index, this value, and then we will multiply index plus 1 by 2, right, based on this formula. Means I can, if I go into write here, so first is what we have value, then what we have, we'll do plus value minus index, right? And now n is, and we know that what we have, n is index plus 1 by 2, that we are talking about here, right? So these are the approach that we will follow, okay, in this part. Similarly, let's suppose we have in the right side we have nums at index is exactly the same. We need to determine the length of the arithmetic sequence and the length of the continuous array with the 1, right, as you can see here, 1 based on the relative size, n minus index and value, right? So this is your n minus 1 and this is your value, right? Similarly, if the value is less than or equal to n minus index, right, n minus index that we are talking about, right, it means that the sub array of the length will become what, n minus index minus value. This will become sub array sum, right, because it consists of all the value of 1 is addition to the arithmetic sequence value to 1. We have taken value and we'll take till what, 1. So from here to here, if you are taking, means this all is consist of 1s, okay. The sum of all the element of the index, right, including nums at index, is made of the two part. the first arithmetic sequence that we can say is starting with the value, then value minus 1, and it will come similarly to like this. Okay, so here if we'll do the calculation, right, this calculation is nothing but what it is saying that if we'll do the sum, right, if we'll do the sum, right, this will become what? This will become value plus 1. We can take value plus 1, value plus 1 into value by 2, right, because this is the thing we have. If we'll do the sum of the length, this will become what? We have taken index, this one, then we'll take what? Minus value plus 1. This is your sum of the sequence. Okay, and this was a sum of arithmetic sequence. Okay, and these all are connected with 1s, and this is actually less than what? n minus index minus value. It is less than. Okay, just that the sum value is coming. So in the otherwise there is only one arithmetic sequence on the right side of the index, right, with the first item being value and the last item being value minus n minus value minus n plus 1 plus index, right, as you can see here, value minus n plus 1 plus index, right, and so this is going to be index n minus 1, right. So if we'll do the sum, right, the sum should be what? Value plus value minus n plus 1 plus index. This will become the sum, and you have to divide by 2, right, because if we are going to divide, means we have to multiply what? We can take n minus index, right, n minus index. See, that part we have to multiply here. Now you have seen everything, these detailed things, right? So we don't need to forget that we have added the actual value at the given index twice. So we need to subtract the final value by sum, right? Now we have seen that how to calculate the array sum at a given a specific value, right? So the question is how do we maximize our value? So we can use binary search to find the maximum value that meets the criteria. First we define a search range from left to right, and that we are going to ensure that the maximum value that falls within this range. Next we will perform binary search within the range, like for each boundary value mid, that divides a current search space in the half, and we try whether the nums at the given index is mid, right? If it is miss, that is feasible value that ensure the sum of the array does not exceed maximum, right? So if it is valid, we continue the search for the larger mid in the right half of the interval. So if it is not feasible, it means that mid is too large. So we need to search for a smaller value in the left half of the interval, and this way we can means we can say in this way we can half the search interval at each step, and we will find the maximum mid that meet the criteria in the logarithmic time. It means there are many problems, right? There are many problems you can say that you can perform the binary search and you can find the optimal solutions, right? You can check out the split array, large sum, maximum distance to gas station, cocoa eating banana, capacity to ship package within the days, divide chocolate, right? Many problems you can go through that. Okay, Now we are going to see the algorithm, right, and we'll try to implement this one. So first we need to define a function that will take you can say index and value, and we will calculate the maximum sum of the given value, that is called num, right. We will initialize left, right, a space, and we'll set a left is equal to 1 is the max minimum possible set, right equal to max for its maximum possible value. Now we'll check left should be less than right. Till that we will get the middle index of the search space and we'll find our mid. So left plus right plus 1 by 2, that is, you can already have the knowledge of binary search. We'll check if the get sum is less than the max sum, right. If so, it means num at index is mid is a valid num, and we can go for the right half by setting left equal to mid. It means the mid is too large and we have the nums, right. So we shall go for the left half and we'll search the space and we'll set the right equal to mid minus 1 and we will return once the binary search ends. So what we have to do actually here, right, that we will talk about later. We will take left, right, and we'll in the while loop we'll take while is less than right, you know the binary search, right. So we'll make a while loop and we'll find our mid and we'll check the get sum is less than the max sum. We'll assign left equal to mid and otherwise right equal to mid and we'll return left, right. So this is the binary search things that you can go through and you'll check. Coming back to the get sum, we have index, we have given value, we have given, and we have given, right. We will take a count, right, and we'll check value is greater than index. We'll find our count. How we'll find the count? Value plus value minus index into index plus 1 by 2. Count we'll find how? Value plus 1 into value by 2 or plus index minus value plus 1, right. Similarly, this is the from left to right to left, right. Now we'll go with the value is greater than n minus index, right. So we'll take value plus value minus n, value plus value minus n plus 1 plus index, and we'll take n minus index that we have seen previously, right. And similarly for this one we'll take value plus 1 into value by 2, value by 2, and we'll do plus n minus index minus value, and we'll return value minus this one because we have already added value each time, right. So we'll return our value. So finally it will return the max value, right, maximum sum it will return. So that's all for today, and if you like this video, please hit subscribe this channel so you will get more understanding, more videos like this. This is little lengthy videos, so don't worry for this. Take some time, pause this video and watch multiple times. Okay, coming back to the time complexity, we have given log of max sum, and because we know that searching a space will take O log max sum, and this step is coming from what? Binary search, right. And we know that each calculation will take O of 1 time, so that's why we'll take log of the sum, but the space will take O of 1 because binary search get function will take O of 1 space. We are not taking any extra spaces, and that's for all today. So thank you for watching this video, guys. If you like this video, please hit subscribe this channel so we'll get more videos like this. Thank you.